머리부터 발끝까지 다 사랑스러워. 네가 나의 여자라는 게 자랑스러워. 기다림을 즐겁.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izhar bin Muhammad Sam, and this is the project for Engineering Mathematics 3. Okay, today I will be talking about the rate of change. The rate of change is basically the application of partial derivative. Okay, let's say if we have a function z equals to fx y, the derivative of z to respect to time will be equal to basically this is the basic equation for the rate of change. Basically this is the equation for the rate of change. If we want to find the rate of change of z with time, so we will have to use this equation, which is we need to find the derivative of z with respect to x, and then we need to multiply this with the rate of change of x with respect to time, and then we need to add the partial derivative of z with respect to y and multiply it with the rate of change of y. Now I'm going to show you an application of rate of change with a problem, and I will show the problem and I will show the solution for the problem. Okay, let's consider that there is a box with the length x, the width y, and the height h. So with given at this instant that x equals to 4 meter, let's say, and y equals to 5 meter, and h equals to 6 meter. Okay, so basically this is the data that they have given to us for this problem, and then we need to find, let's say, the surface area. For the surface area, they need to give us the rate of change of x, y, and h with respect to time. So let's say dx over dt is equals to 0.5 meter per second. dy over dt equals to 1.8 meter per second, while dh over dt equals to 0.9 meter. Okay, to find the surface area, first we're going to need to write the general equation of the surface area, which is S equals to, okay, let's show how I got all of the surface area. First there is x multiply with y, x plus y plus, and then there is surface y multiply with h, and then there is another surface area h multiply with x. and then we need to know how much the surface area of each of these section. So we need to identify and determine the surface area for this. So for the first part is x multiplied with y. So basically this is the area of the surface. So we need to determine the same surface that has the same area or same dimension with x and y. So there is another one. So we got 2 here. So for h and y is here, h and y, and then there is another surface. Okay, let me show you. So this is the surface of h multiplied with y, and there is another one surface. So basically it's also 2 here, and same goes to h multiplied with x, which is here at the front, and then there is another at the back. So it's also 2. So what we need to do is we need to form an equation that to find the rate of change of surface area. Okay. So to find the rate of change of surface area with respect to time, we need to find another equation. We need to write an equation to describe the relationship, which is ds So this is the equation for the rate of change of surface area. So we need to, okay, we show how I got this equation, which is partial differential of surface area with respect to x, which is the rate of change of the surface area with respect to the change of x. We need to multiply it with the rate of change of x, and then we need to add with partial differential of surface area over delta y, and then we need to multiply it with the rate of change of y, and same goes to the h part. So what we need to do is we need to find the partial differential equation of surface area based on this. From this equation we need to come up with this, and this. Okay. For the surface area, for the partial differential equation of s with respect to x, we will get 2y plus 2h, and then this is, we need to plug in here. We have been given the rate of change of x with time is 0.5. Same goes here. We need to do a partial differential for surface area with respect to y. Plug in the rate of change of y. Okay. From this equation, we need to plug in the value of y, h, and x from the value that have been given earlier at the instant. So for this equation, we need to plug in the value that have been given on top of that. From this, we need to calculate it by using calculator, and we will get, for this part, we will get 63.2 meters square per second. So that's how we use partial differential. That's how we use partial differential equation to find the rate of change of surface area. Another application of rate of change is we can find the rate of change of the diagonal length of the box with respect to the rate of change of each side that have been given earlier. So let me draw the box back. Okay, let's say if we are required to find the rate of change of length of diagonal of the base of the box. So first we need to identify which one of these is the length of the diagonal at the base. So this is the base here, base. So we need to find out which one of the area is the diagonal. So as we know, the diagonal will be the length from the angle here to the other side. This is D. So D will be equals to the diagonal length will be square root of x square plus y square. So this is, from this we need to write an equation of the rate of change, which is basically this is the equation of the rate of change of length of diagonal of the base of the box. Okay. From this equation we need to do a partial differential for the equation for D. So if we want to find out what is the value, we need to differentiate it. Okay, the partial differential of D with respect to x will be equals to x and then we need to multiply with 0.5. We just need to plug in the value that have been given earlier. So this section is y over square root of x square plus y square multiply with 1.8. So to solve the rate of change, so we need to plug in the value that have been given for each x and y. So x here will be 4 0.5 plus 5 over so if we calculate it by calculator, we will find out the answer will be 1.72 meters per second. So this is the rate of change for the diagonal length of the base with respect to the changes that have been given earlier. First, we need to know how to write the equation for the volume of the box. The box is basically just a cuboid. So the equation will be the volume will be the length times the width and the height, which is x multiplied with y and multiplied with h. So from this equation we need to form another equation, which is the equation for the rate of change of the volume, which is dv over dt. So as usual, we need to do partial differential equation. This is the equation of the rate of change of the volume. So from here we need to do some partial differential equation. So we need to differentiate the equation of the volume partially with respect to x, y and h. So for this section we need to do the partial differential of the volume with respect to x, which is YH. So YH will be multiplied with dx over dt, which is 0.5. So same goes to the other part. For this part we need to differentiate the equation of the volume partially with respect to y. So from here we have obtained the basic equation for the rate of change of the volume with respect to time. So from here we need to plug in the value of x, y and h with the value that have been given earlier, just like before. So this is 5, 6 times 0.5 plus 4 times 6 multiplied with 1.8 plus so we need to just key in the calculator with the value that we have written on this whiteboard, and we will get the answer will be 76.2 meter cube per second. So this is the rate of change of the volume for the box. So that's how we use partial differential equation to find the rate of change. Thank you from me, Muhammad Izzat bin Muhammad Sab.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Nur Aimita Rosli. I'm going to present from chapter 2, which is multiple integral, subtopic double integral. For the question, evaluate the following integrals over the given region D. Double integral 4xy minus y cube dA. D is the region bounded by y equal to set x and y equal to x cube. In this case, we need to determine the two inequalities for x and y that we need to do in the integral. First of all, we draw the line for y equal to x cube. Then we draw the another line which is y equal to set x. When the two lines intersect, then we obtain the region D. So from the sketch, we can see that two inequalities are 0 less than equal x and x less than equal 1. Then for the second one is x cube less than equal y, and y less than equal set x. Now we can do the integral. Then we insert the inequalities into the question. After that, we integrate dy and we get 2xy squared minus 1 over 4y the power of 4, and we substitute the value of limit. After that, we integrate for dx and we will get 7 over 12 x the power of 3 minus 1 over 4 x the power of 8 plus 1 over 52 x the power of 13. Then we substitute the value of limit and we will get the answer, which is 55 over 156. That's all for me. Thank you. 56. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazira binti Abdul Ghani and I'm going to solve the problem regarding the topic of curvature from the chapter 3, vector valued function. Before we solve problems, here are some short notes regarding this topic. Curvature at a point measure how sharply the curve bends or how quickly it changes directions. More formally, the curvature measure how quickly the directions of unit tangent vector changes with respect to a change in arc length. Here's, or we can written it as st. Okay. Next. Okay. The curvature of line is equal to 0 because whenever we draw a line, whether slanting or straight, we can see from here that there is no bend or any curve. So that's why the curvature of line is equal to 0. But the curvature of a circle is equal to 1 over r. Here we know that the curvature is inversely proportional with r. Okay, so when the r is small, r here is represent the radius of a circle. Okay, when the r is small, the radius is small, the curvature of a circle is higher. So we can, and vice versa, and we can conclude that for a small circle, the tendency of the unit tangent vector to change its directions is very quickly. Okay. Now focusing on our subtopic, which is vector valued functions. When we are given vector valued function and we need to find the curvature, here's the formula. The curvature of a circle is equal to the magnitude of the dt over ds, or we can written it as the magnitude of the first derivative ts. Notice this, ts must be defined in terms of arc length, which is s. Sometimes when we trying to get the derivative of the unit tangent vector, it can be quite messy. So by using this alternative formula, it will be very helpful. So the formula is equal to the magnitude of the first derivative of rt cross product with the second derivative of rt over the magnitude of the first derivative of rt powered by 3. After this, we're going to solve problem by using both formula. So for questions number 1, okay, we are given rt is equal to 2 cos t and 2 sin t. From here we need to find the curvature. So the first step is we need to find the unit tangent vector first by using this formula. Okay, rt to the magnitude of So from here we need to find the derivative equal to 2 negative sine t and 2 cos t over the magnitude is 4 sine square t plus 4 cos square t, and we put the square it. We need to square both. So here we simplify it by factorize the 2 over 4 sine cos square t plus we get 2 sine t cos t over 2. Here, this trigonometry we can simplify it by using the trigonometry identities. The one. So, into 1. Okay, now equal to, we cancel out both 2 and we get sine t cos t. Okay, next. After we get the unit tangent vector, negative sine t cos t, we find the first derivative of unit tangent vector and we get negative cos t over negative sine t. Okay. Then we find the magnitude for the first derivative, which is cos t plus sine t, and square root, we get 1. As for the magnitude of first derivative of RT, as we have calculated before here, and we get here, here, so we just copy it back. 4 sine square t, 4 cos t square t, and we will get 2. So the final answer, since the formula of k is equal to magnitude of t over the magnitude of v plus we will get the formula is 1 over 2. Okay, for questions 2, we need to determine the curvature at t equal to 1 of RT is equal to t square over 2 and 3 cube over 3. Okay. For these questions, also first we need to find the unit tangent vector first. Okay, equal to, by using the same formula, we need to use t square over 1 plus t square plus t powered by 4 and square root. Okay, so first derivative of RT is 1 t and t square, while the second derivative is 0, 1 and 2t. From both, we need to do a cross product. Here are first derivative of RT, cross product with the second derivative of RT. Then we get Ijk with 1 t square, 0, 1, 2t, and we will get the answer is 2 square, negative 2t and 1. Thus, the magnitude of this cross product need to be identified, and we will get t plus 4 square plus 1. So we put the value when t is equal to 1. The magnitude of the cross product will be 1, 6. So by using the alternative formula, which is stated before, k is equal to 6 over 3. So we simplify it by this, equal to 6 equal to we cancel out both square root of 3 and we get the answer is, or approximately 0.47. So thank you for watching the video, and I hope this video will be very helpful.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfati binti Muhammad Latif. I'm going to present a question from Chapter 4, Vector Calculus, subtopic Stokes Theorem. The question is, use Stokes Theorem to evaluate f dot dr where f equal to z square I plus y square j plus xk, and C is the triangle with vertices with this one, coordination in counterclockwise rotation. First, to solve this question, we must know the Stokes Theorem equation, which is this: f dot dr equal to this one dot n. Secondly, I sketch triangle where the question mentioned in the coordination, which is this drew, and this is the projection on xy plane, which is when on xy plane the equation is different, which is y equal to negative x plus 1. So to solve this problem, we need to find this one and this. To find this, we have to use matrix, which is this. Z square, y square, and x is found in this question, which is this one. F equal to z square I plus y square j plus xk. After we do this, we obtain the equation, which is 2z minus 1j. To find n, we use this f x y z, and we got the answer, which is n equal to I plus j plus k. After we found both, we substitute it in the equation. This is, so we substitute all the unknown we have, which is this. This limitation we found at the limits is from this 1 to 0. Everything is 1 to 0, and the second one is this one, 1 to minus x plus 1 to 0, which is why the limitation is different. So first we integrate the inner part, not the outside part, the inner first, which is dy. So when we integrate, we able to obtain this one, y minus 2xy minus y square. So we substitute the limitation in the y, so we obtain x square minus x. After you obtain this, we do second integration with dx. So we obtain 1 over 3x cubed minus 1 over 2x squared. So we substitute the limitation. And we obtain the answer, which is minus 1 over 6. So I obtain the equation, which is f dot dr equal to minus 1 per 6. That's all from me. Thank you.